So we're going to be using the calculator to find here when the derivative values are not so pretty. Okay. So the first calculator is I want you to go put the function 3e to the x sine of x. I want you to put that in your y1. So go to y equals and type in your function 3e to the x and then sine of x. The easiest way to put this information in your calculator and get the calculator to do the derivative for you is to type it into y1 and store the function there. Now, because my calculator is a little bit blurry, I'm going to go back to the whiteboard and type out the steps for you so you can see them. So Anthony, do you use a school issued calculator? Is that what you use when you are in class? Okay, then you're going to want to use the Desmos graphing calculator. You can just Google Desmos graphing calculator. It's not going to have all of the same features. I'm going to be honest with you. It's not going to have everything that we're going to be doing here. And you can't use Desmos graphing calculator on the test, on the AP exam. But it is what we can do right now. Okay, so you can probably use that. You can use an app for the 84. In fact, I like to use TI. I don't remember what it's called on the iPhone, but on the Android, it's called Wabbit with a W, and it basically puts this graphing calculator on your phone. Has the same keystrokes and everything. Okay, so once you have your function in Y1, then the next thing that I want you to do is to go to your home screen. The way you do that is you press second mode. So second mode takes you back to your home screen. And I'm typing my steps in the chat here so you can see them. Now we have to tell the calculator, hey, we want the derivative at -2, since that's the value we want the derivative in our chart. So you're going to go to math. So find your math button. And you're going to go to number 8, in derive. So you can use your arrows down to get to in derive. Or you can just type the number 8. The choice is yours. Okay, so now your calculator has put this d over d. So it's saying, what do you want to take the derivative with respect to? So we're going to type an x in there. You can do this on your calculator by just using that variable key. The next thing is it's saying, okay, what do you want to take the derivative of? So you want to put in this is where you're going to tell it y1. Now the way you do get y1 is you use your vars key. So use vars and then use your right arrow for y vars and you want function. And there you can choose y1. So let me go over that again. That is vars and then you go right arrow to y vars, and then you choose function, and then you want number 1 for y1. Now, keep using your right arrow because we're going to tell it at what value of x we want, and we're going to type in -2 because we want the derivative of the function we typed in y1 at -2, and you can press enter. Your calculator should return a value with 3 decimals in it. I'm going to do a quick check here and make sure. Oops, mine's not right because I wasn't in radian mode. I had a suspicion that that might be. So let me just recall that again. And you should get negative 0.538. Take a minute, see if you can get negative 0.538. You got, was it a syntax error, Catherine? What exact type of error was it? Type error, okay. So go back to your Y1 and let's see if you have 3e, so remember that was our function, 3e to the x, and then come down and do sine of x. That should be your Y1. Perfect, okay. Then go back to your home screen, and when I typed mine in, guys, this is what mine looked like, d over dx, and then beside that was a Y1, and remember, I can't just type a Y and a 1, I have to go get the Y1 label, and then I have x equals negative 2. And the way I go get the Y1 label, I do vars, y vars, function, and number 1. See if that fixes your problem there. Let me know. You can, Saida. Yes, you can type the function itself. The reason I did not is because I'm going to show you a second way to do this that requires that it has to be in Y1. Okay? That's what I got, Emerson, negative 0.538. Well, Emerson, if you put it in Y1, it'll always be in Y1. It's up to you, right? Okay. Now, friends, couple of things about AP. AP is 3-digit rounding, always and forever, not 3 sig figs, but 3 digits. Okay, so 3 decimal places. That's AP rounding all the time. Now, look at the column on the far right. It asks us if f of x is increasing or decreasing, or does f of x have a horizontal or vertical tangent? So based on my value here, my derivative is negative. Tell me in the chat, am I increasing, decreasing? Do I have a horizontal or a vertical tangent? Which one do you think I have, guys? I like it. Yes, decreasing. Very good. And the reason we're decreasing is because the derivative is negative, right? Derivative is negative, therefore my function is decreasing. Yep, I'm going to redo it here in just a second. And in fact, I'm going to do number 2, but I'm going to show you a second way to find the derivative with your calculator, and you can use either one. So this is way number 1. It's math in derive. The second way, and I'm going to do this with number 2 in our chart, notice it's the same function. So I don't have to go type anything different in Y1, but I'm looking for it at a different value. So let me show you the second way. The second way to find the derivative with your calculator is to graph the function. So go ahead and graph. Man, I've got a stat plot on, so let me turn that off. So I'm going to turn my stat plot off so that when I graph, let me do a zoom 6, so that when I graph, I get just my normal graph, no scatter plots going on. Now, in order to find the derivative from the graph, you would do second trace. Once you have the graph, you can use second trace, oh, not trave, trace, to find your derivative. Now, we're going to choose option number 6 here. And look at what the calculator is asking you. It just puts a cursor there. So you technically could move your cursor around to get to the point you want the derivative. However, I want it at 1. And instead of moving my cursor around, I'm just going to type 1. When I type 1, notice at the bottom of my calculator screen, it puts x equals. So that when I typed in 1 and I press enter, it tells me the derivative at this point, and I get 11.268. It's the same value I would have gotten had I done inderive again with x being 1. But this is a second way that you can get the derivative. Now, I also want to point out one thing. That when you do it with the graph, you get the derivative, but look at what else you get at the bottom of your screen. You get x equals 1 and you get y equals 6.862. So in doing it with the graph, you get not only the derivative, but you get the function value as well. You get the y value and you get the value of the derivative. So it doesn't matter to me which method you want to choose. Either one works for me. But I want you to take a minute now. Oh, we didn't finish this one. So number 2, are we increasing, decreasing, horizontal tangent, or vertical tangent? What do we have here? Tell me in the chat there. Saida, do you have an 83 by chance? The 83 did not put the value of the function down there. It did not. Okay, you have an 84 plus. Okay, plus. Okay, mine's an 84 plus C. That may be a difference. I don't know. I'm not as familiar with all the versions of the 84, but that may be why. Okay, friends. So what I'd like you to do, there are 4 more on this page. I want you to go ahead and find the values for the derivative for the remaining 4. This is simple as typing in new functions, using either inderive or using the graph. Either one will work. I'm going to slowly make my process through it. That way you can look at them, what I've got. Okay, thank you. Ashley is talking to me about calculator. If you don't have an 83 or an 84, you might have an 89, which is allowed on the AP exam. If you don't have either one of those, I do probably suggest doing one of the apps on your phone. The one on the iPhone that I found that was really, really good is only like $4. The one on the Android that's really good that I mentioned earlier, the Wabbit, it is completely free. So feel free to use that one. So take a minute. Let's go ahead and find the values of these derivatives. as always, remember when you're using a trig function, make sure you are in radian mode. You saw me earlier that I was not in radian mode and it caused me to get a wrong answer. So make sure you have that. And of course, with AP, we're going 3 decimal places here. So I'll encourage you to do the same. So it looks like I got negative 0.372, and that is decreasing. Now, if you know a little bit with the 83s and the 84s, you know that if you're going to use the same, I'm using the same function. So I'm just recalling, and forgive me, I'm changing layouts again, and I didn't mean to. I'm just recalling my previous statement. So I'm just pressing second enter. It recalls what I did before, and that way I can just go type in a new value for X. Okay, work smarter, not harder, right? So you're going to use those features as well. Anthony, great question. Oops, I typed something wrong. Great question about why radians. And the answer is because when we deal with trig functions and we want the values, we want to use values like pi and pi over 3 and things like that. That's in radian measure. So we have to tell our calculator, hey, everything we're giving you is in radians. Let's stick with it. Otherwise, I've got to go back and adjust my X values to accommodate for being in degree measure. Okay, so what happened with mine? Because it gave me an error and non-real answer. Ooh, this is a good one. Okay, I'm with you now. Somebody want to tell me why I'm getting an error? I checked my function. It's typed correctly. On number 4, I'm getting an error. Anybody want to take a guess at why I'm getting an error here? My error, notice, says non-real answers. Why would I be getting an error that says non-real answers? Good guesses. What number doesn't exist? I love your thinking of all these ideas. What number does not exist? I agree with you that we're going to get a vertical tangent. That's in the far right-hand column, okay? Okay, 0 in the denominator, but I have pi in my denominator, okay? Here's the reason why. Okay, you're right. The derivative at pi is undefined. That is the right statement. But here's why. Look at the top. You've got cosine of pi, which is -1, and then you asked it to do the ln of -1. Or if you somewhere in the derivative, right, you're going to have this ln of cosine, right? You're putting in pi, ln of -1. What's wrong with the ln of -1? Someone tell me, please. What's wrong with the ln of -1? Exactly. The domain for the ln of x is that x has got to be greater than 0. So when you tried to get ln of -1, I can't even do ln of 0. It's got to be greater than 0. It's got to be positive. That caused us to have an undefined value at our derivative. These ln's, they keep coming back at us. All right, friends, let's keep going. We've got number 5 next. I've got to type it in. I've got a new function in my Y1. So I'm going to type in e to the tangent of 0.34x. Let me close it up. I'm going to go to my home screen by doing second mode. I'm going to recall that previous statement by doing second enter. And I'm looking for the x value of 0. So I typed that in. Let's see what I get. And I get a nice value, right? This time I got 0.340. 0.340. That's positive. So I know that this function is increasing. All right. One last one. This one's tricky here on number 6. I'm going to switch over to my whiteboard so you can see how I'm going to actually write it out. So you'll see how I'm going to type this one in. Because of the sign squared, this one requires an extra set of parentheses. So I've got to do sine of the ln, right? Close the parentheses on the ln of x, close it for the sine, and then square it. So let's see if we can type that into y1. I've got 5 parentheses sine ln of x, close the parentheses for the x, close the parentheses for this ln, close the parentheses for the sine, and square it. Let me show you guys what I have typed here. See if I can make my calculator screen a little bigger. Notice what that looks like when I typed it in. That's a lot of parentheses on the back end, but every one of them is necessary. Let me go to my home screen now, second mode, recall it, second enter, because I want the derivative of y1 again, and I want it at the value of 1. Ooh, what is this? So my calculator is registering a negative 5.0000083 e negative 6. Somebody translate that into real talk. What does that mean? What is that number? What does that E mean on my calculator? And why did it do it? Calculator's telling me negative 5.000000083 E negative 6. What is the calculator trying to tell me there? Saida's right. That means 10 to the negative 6. Super small, right? Really, 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 really close to 0, right? And in fact, sometimes the calculator gives us this value when it really should be returning the value of 0. Has to do with the way the calculator approximates these values. Okay, so we actually get the value of 0 here. Now, if the derivative is 0, am I increasing, decreasing, horizontal tangent, vertical tangent? Which one am I at this point? Derivative is 0. That means that I'm horizontal. Yep, because the slope of the tangent line would be 0. So I've got a horizontal tangent there. All right. Very good. So far, so good, friends. Now we're going to continue this idea with the graphing calculator. I want you to go to page 235. Okay. Page 235 tells us that when the value of the derivative of the function is positive, we say it's increasing. We did that. You and I already did that, okay? We're going to look at number 7, and I want you to remember we're going to use our calculator here. So take a minute to read number 7. And we're going to do A. And we are going to let the calculator do the hard work. So for A, I want to put in my function into y1. So I'm going to type in y1, 560 e to the sine of t. Okay, so let's do that on our calculator. We're going to put our function into y1, let the calculator do the hard work. Put our e in, our sine. We're going to go ahead and use x instead of t. Now your calculator does understand t, and maybe in your pre-calc class you did a little bit of parametric equations where you used t, but in our case we're just going to keep it in function mode and do x instead of t. Now the first thing we're asked on 7a is to find the function at 1/2. Your calculator knows how to do this. Totally fine. So we're going to do that. The easiest way to do that is to go ahead and graph this function. And this was one of the reasons why I showed you the second method, because if you want to find the function, the easiest way to do that is from the graph. And so we're going to do second trace, and we're going to choose option number 1. Option number 1 is the value option. You may have used it before. We're going to press enter for number 1, and then down at the bottom of your screen, you should see an x equals. I'm typing in 1/2. You can type in 0.5 if you want. Calculator knows the difference, and we get a value. We get 904.482. Okay, now I know it says to use correct units, explain what each value represents. I'm going to do that here in just a second. I want to go ahead and do the rest of our calculator work first. And the next thing is it asks us to do is to find f prime of 1/2. So you remember how we did that in the second trace menu. We're going to go second trace, and this time we're choosing option 6 to find the derivative. Remember, you can use your cursor around to find 1/2, or you can just start typing 1/2 and an x equals will appear in at the bottom of your screen. And it tells us that the derivative at 1/2 is 793.757. All right. Questions about how I found either of those values? Okay, let's add some units then. Okay, look at your function. This is where we got to come back. It says the number of people entering a concert can be modeled by the function. So that means when you get a function value, that's the number of people. The number of people entering a concert at, let's see, T is the number of hours. So at T equals 1/2 hours. You could even say something to the fact of, this is the number of people entering the concert after the gates have been opened for 1/2 hour. All right. Now the derivative gets a little bit trickier because remember, the derivative is a rate. It's a rate at which the function is changing. So if the function is the number of people entering a concert, then the derivative is the rate of people entering the concert per hour, right? That's our rate at t equals 1/2 hours. So the function, yes, Saida, it is a speed. Well, it's kind of a speed. We have to be real careful that we don't use speed because speed does not have direction. So if we have speed with direction, we have velocity. So we have to be real careful with that language there, but it's the same concept. All right. Notice the calculator did the hard work, the function work, the derivative work, but I had to do the interpreting. Okay. Look at B. Look at B for number 7. How many people have entered the concert 2 hours after the gates are open? Tell me in the chat, is this looking for the function or is this looking for the derivative? How many people have entered the concert 2 hours after the gates are open? Am I looking for the function or am I looking for the derivative? I'm going to let the calculator do the work. I just want to know which one I'm looking for. Yep, looking for all the fun. Right, okay. So we're looking for the function at 2 hours. Again, going to my calculator, I've already got the function in Y1. I can do second trace value and type in a 2 for 2 hours. And the calculator tells me there are 1,390 people. Did you notice I didn't round that one? I did not round with 3 decimal places. Somebody tell me why I didn't. Somebody tell me why I left that at 1,390 instead of using 0.244. Yeah. People. You can't have 0.24 of a person, right? Little brother's not included, right? Okay. Last one then. It says, is the number of people entering increasing or decreasing at this time? So to know that, I got to find the derivative. So the derivative at 2. So second trace number 6, and then type in your 2 to get your derivative is negative 578.545. Because it's negative, I know the number of people entering is decreasing. Because, remember, anytime you see that, justify your answer, because f prime of 2 is negative. Let's go ahead and finish up number 8 here. We are being given a function and we're asked for the temperature of the coffee 5 minutes after it's been poured. Think to yourself, is this the function or the derivative? Well, it should be the function. So we're going to type in our function into Y1, changing our function here to 70 plus 110 E to the negative t divided by 2. And then remember, we want the value. So we're doing second trace number 1 and just type in 5. And it looks like I get 79.029. Check my units here. It tells me that's in degrees Fahrenheit. So it's a good habit to go ahead and get into that. Okay, so B asked me, is the temperature decreasing faster 1 minute after it's poured or 3 minutes after it's poured? So what we're looking for is we're looking for the derivative, right? The derivative at 1 and the derivative at 3. So we'll use our derivative function here, second trace, option 6. Let's type in 1. We're told that the derivative at 1 is negative 33.359. And the derivative at 3, again, second trace, option 6. And it looks like we have negative 32.363. So it looks like it's decreasing faster at this rate. Think about it, decreasing faster, bigger negative. So the temperature is decreasing faster at or after 3 minutes because after 1 minute, because t prime of 1, or maybe I should say the absolute value of t prime of 1 is greater than the absolute value of t prime of 3. A little bit tricky with that bigger negative. I had to think about how I could say that with the bigger negative. So I hope that helps for today.